Okay, so we're going to start graphing linear equations. And when we are graphing linear equations, one method that they talk about is this systematic approach. And within that systematic approach of graphing linear equations, let's back up here. What was an example that I had? We had 2x plus 3y equals 6. So 2x plus 3y equals 6. Okay, so solve the equation for y is going to be the first step. You've been solving some equations for a particular value. You did that last year. So if I take 2x plus 3y equals 6, I want to solve it for just y. And I'll just tell you this much right now. You're going to get y is equal to negative 2/3 x plus 2. You're going to get something like that. So the first thing they want you to do is they want you to solve for y. The second thing they want you to do is they want you to make a table and select convenient values of x. So something you may have seen in the past is you're going to make what is known as an xy table, and you're going to pick convenient values for x. It sounds like in my little world, put your little tree. Bob Ross. This is what this seems like. Just convenient little values. I don't care what values you pick. You can pick any values for x, but they want them to be convenient values. If I pick 1 for this example I have up here, I'm going to get a fraction involved, and fractions are going to be hard to graph. So since I had a denominator, I picked the positive and the negative of those values, of that denominator value. And 0 is always easy. But after you do that, they say use these values of x in the equation to find the matching value of y. So I would take this negative 3 and I would put it into the equation. So I'd say, oh, negative 2/3 times my x value of 3 plus 2. And then I would solve and find the value. So negative 2/3 times 3 is negative 2 plus 2. I get 0. So I would come to my table. The next part, number 4, says complete the table. So in my table of xy values, if I pick this negative 3, I end up with a y value of 0. So I would do that for all points that I find as convenient points to pick. And then 5 says graph the ordered pairs and draw the line. So I would start plotting these points. If x is 0, I put it into my equation. Negative 2/3 times 0 is 0 plus 2 gives me a value of 2. So I got to know how to plot those points on the xy axis. Okay, I wouldn't go to a lot of work sitting there copying all those steps and panicking about it. I'm going to show you, but I wouldn't worry about, oh, I got to do this, then this, then this, then this, then this for right now. I will post this up so that you can get it if you need to see it. But I think as I go through graphing it, you're going to find out that you don't need to write all those steps down. But they talk about those 5 steps. You can always do this for any graph that you have. Anytime they ask you to graph. Calculus, we just went back and started graphing some things like this, just to make a point about something. Then we start talking about easier ways to do it. So let me give you an example right up there. Now we're going to get into that example a little bit better. So if I give you, let's just go ahead and work through it in blue, I think. If I give you the equation 2x plus 3y equals 6, and I ask you to graph. Remember that first step said solve for y. So to solve for y, I'm going to move the 2x over to the other side. And I get 3y equals 6. Actually, I think last year I told you you want to put that x first. It's negative 2x plus 6. Those are not like terms, so you can't group them together and say it's 4x or something like that. Everybody's okay with that? That first step, solving for y, isolate the y. The next thing we need to do is get rid of the 3. So to get rid of the 3, I divide by that 3. And if you divide the right-hand side by 3, you actually split it into 2 fractions. So I have negative 2/3 x, and 6 divided by 3 is 2. So that's how I obtained this equation right here I just kind of went through it mentally though. But that's how I obtained that equation. The second step that we have said to create a table. So I'm going to create this table. And I'm going to come up with coordinate points. So as I come up with coordinate points, it says pick convenient values for x. Well, what are convenient values? We don't want fractions. So I'm going to look at what this denominator value is. And I'm going to pick the positive and the negative value of that denominator along with 0. And on the previous slide, we already looked at how we can solve. Now what you're going to do, okay, here's where we are. We're making a table and selecting convenient values for x. Now step 3, use these values of x in the equation to find the matching values of y and complete the table for step 4. So I'm going to do that. I'm going to put it into the equation. I have negative 2/3 times x, which is negative 3, plus 2. Maybe I had a sign error on the previous slide. Maybe I put in 3 instead of negative 3. Sorry, it's going to bother me. Oh, I said 3 right there. I'm going to change that to a positive 3, okay? Since that's what I substituted in over there. All right, so what is negative 2/3 times negative 3? Negative times a negative is a positive, and you get the 3's cancel. So you get 2 plus 2, which is 4. So my y value is 4 if x is negative 3. What happens if x is 0? Well, negative 2/3 times 0 is 0, and I just get 2. Now what happens if x is 3? If x is 3, the 3's cancel, or you get negative 6/3, which is negative 2. Negative 2 plus 2 is 0. I filled out my table. You could pick 1, but if I pick 1 and I put it into this equation, I get negative 2/3 times 1 plus 2. Well, that's negative 2/3 plus 2, which is equal to 1 1/3. And how am I going to graph 1 1/3 on my graph? Get that big graph paper? So it's not as easy to do, but you could pick it. All right, now I have this table, and what they say is I need to plot the values. Which axis is your x values? Do you know that? Is it the horizontal or is it the vertical? Horizontal. So the x-axis is my horizontal axis. So here is x, here is y. So I'm going to plot these coordinate points. Where's negative 3, 4? Where do I go from the origin? Back 3 and up 4. So there's a point. I'm going to plot the point 0, 2. So I go from the origin and I just go up 2. Now I need to plot the point 3, 0. So from the origin, I'm going to go to the right 3 and move 0 on the y-axis. If I look at that, I have the graph of my line. And I've graphed my line. Oh, man, lots of stuff involved. Solve the equation for y. Create a table, pick convenient x values, find the corresponding y values by putting it into the equation, then plot the points. Instead, I mean, that's very accurate. Why did I pick 3? Because it takes 2 points to create a line. Exactly 2 points create a unique line. If I would have calculated one of those incorrectly, then my graph would be wrong. But if I get 3 points and they're all in a straight line, I'm pretty sure that that's what my line is. Now what we could do to make it a quicker way that's just as accurate, it can be just as accurate, and that's to use something called the intercept slope method. 2 points determine that unique line, and the 2 points we are going to use is going to be what is known as the y-intercept, and the other one is the slope. What can you tell me is, what do you know about a y-intercept, or what does that mean? What is a y-intercept? Where it crosses the y-axis. If I go back to my graph right here, this is, I don't want that color. This point right here, where y is 2, that's considered your y-intercept, because that's where it crosses the y-axis at. So when we use this method, I'm going to use that point and a slope. But we need to understand a little bit about the intercept-slope method. In the intercept-slope method, you get the equation y is equal to mx plus b. M is your slope. You will have a number in this position and in this position. We just had that in the last equation. What did our last equation look like? The equation we had was y equals negative 2/3 x plus 2. In that example, what is your slope? That's your m value, which is the coefficient of x. So my slope is negative 2/3. B stands for the y-intercept. The value that's in that position is 2, so my y-intercept is 2. You have 2 points. Slope means rise over run. It means the change in y over the change in x. You've got to rise up before you run. You got to get up out of bed before you take off. The sun has to rise before it runs across the sky. So if I wanted to graph this, the first thing you have to do is solve for y. We already did that. That's the same equation. We had this equation right here. Y is equal to negative 2/3 x. Uh-oh. I went part of my marker. Plus 2. This is how simple you can graph it instead of memorizing those 5 steps. You start with what is the y-intercept. That's a point. I'm going to start right there. That's where it crosses the y-intercept at. From that, I'm going to work with my slopes. This slope right here. Which way does a positive slope go? Do you know? A positive slope goes this direction. A negative slope goes this direction. And if I look at it, I can spell the word negative out of it. And I have older students that remember it because of that right there. We'll look at slopes a little bit more tomorrow, but that's where you get a negative slope from. It goes in that direction. So from here, remember that slope is rise over run. How far up do I want to rise from this point? Well, what's your rise number? 2. So I'm going to go up 2, and I'm going to run how far? 3. So I'm going to go either back 3 to get this point right here, or I'm going to go to the right 3 to get this point right here. But which one's going to give you a negative slope? The one to the left or to the right? To the left. So I go to this one to the left, and this is the point I want. I do not want this point over here. The other thing you could do is I could go rise, I could drop 2. So what happens if I drop 2 and move 3? Which way do I want to move 3 now so I get a negative slope? To the right. So I'm going to go to the right 3. And if I connect those, does that look like the same line that I had before? Yeah, it's the exact same line that I had before. And if I look at these points that I have this point of negative 3, 4. I have this point of 0, 2. And I have this point here of 3, 0. Those were points that we had before in an XY table. Wasn't it easier to get them by just finding this point right here and counting instead of putting it into an equation and finding the values? Much easier. So tomorrow, I'm going to tell you a little bit more about what is a zero slope, what's an undefined slope, and then we're going to look at some more examples in the intercept slope method. That's a quicker method to solve or to graph an equation. Great. We will do that on Monday because it's study hall tomorrow. Lucky you guys. Have a good day.